Okay, the usefulness of this form here that we ended the last video on is simply that it's quite intuitive once you understand what's going on with a graph. So the situation that this addresses is a point on a graph with coordinates x0 and f of x0. Okay? Now you can see that if I subtract x0 from both sides, I've got y minus x0 here, and I've got x minus x0 here, and I've just got equals f prime of x0 times that. My y minus f of x0 is like a y minus y1, where y1 is your f of x0, and this is like an x minus x1, where x1 instead of x1 is x0, okay? And this f prime of x0 is the derivative at this point, which is the slope of the tangent line. Okay, so this does represent the tangent line. Now, let's see what this form tells us. Okay? Now, I want to come down here before I do this in symbols. What I'm after is the coordinates of the point on the tangent line, where the x-coordinate is just x, variable x. So the y-coordinate of this line is a function of whatever the x-coordinate happens to be. Down here, okay, we got the point 2, 3, and we assert a slope of 2/5. Okay. Now, what are the coordinates of the point where the x-coordinate is x? In other words, what's the y-coordinate if the x-coordinate is x? Okay. Well, what do we know? It should be reflex, and this reflex should be bred into people starting with Algebra 1 or at the latest Algebra 2, the first time you see a straight line. Between 2 points of that line, you draw a triangle whose axes are respectively parallel to the x and the y axis. I could draw it down here, or I could have drawn it up here. I'm going to have a right angle here, okay? And this side is going to be the rise between these 2 points, and this side is going to be the run. So that the slope equals rise divided by run. So and in this case, the slope would have to be 2/5. Okay, well, if this point has x-coordinate x, y-coordinate unknown, that allows you to write the expression for either the run or the rise. Now, can you write the expression for the rise? What would you have to know in order to write the expression for the rise? Okay, well, hint, you'd have to know this coordinate and the y-coordinate of this point, which you do know is 3. Well, you don't know this coordinate, so you're not going to be able to write an expression for the rise. Can you write an expression for the run? Pause and see if you can do that. Now, if you've given up or if you got it already, either way, the run is going to be the difference of the x-coordinates. X-coordinate of this point minus the x-coordinate of this point. If you don't understand that, you really do need to stop and ponder it. But if this point has x-coordinate x, and this point has x-coordinate 2, then the run is x minus 2. Okay, now we don't know what the x-coordinate actually is, but we have represented it by the expression x, so that whatever the x-coordinate is, this is the expression for the run. And if you have a number for x, you put it in here, and you get the number for the run. Okay, so the run is x minus 2. Okay, well, we've got this thing says slope equals rise divided by run. Okay? So let's replace this question mark by y, but we'll keep a question mark over it because we're going to assume that we don't know the value of y. Still, we want to write the expression. Now we're assuming we know x. We don't know y, but now we see that we could write the rise as y minus 3. Okay? So now our equation is what? Our y coordinate. Well, we can write slope equals rise over run. That tells us that the slope, which is 2/5, equals y minus 3 over x minus 2. So y equals what? No, sorry, y minus 3. Let's do that first. Y minus 3 equals 2/5 times x minus 2. If I add 3 to both sides and put the 3 down first here, I get y equals 3 plus 2/5 of x minus 2. Okay? Now this is in the same form this is. Okay? I get my y by taking my f of x naught, which would be my y value at this point. Now that would be 3 in this case. 3 at this point, sorry. That would be 3. And then I take 2/5 of my run. 2/5 of x minus x naught. That gives me my rise. Okay? So I could say that y equals careful, y naught plus what? Slope times run. Okay, 2/5 of x minus 2 is 2/5 of the run, and that should be the rise, which would be y minus y naught. Okay. This equation here would be, well, I don't have to write it again because I already had it here. Rise over run equals slope. Rise over run equals slope. Arranges to y equals original value of y plus the slope times the run. Okay? Now how does that apply up here? Well, we do the same thing. We always do this, what I call slope triangle. This is an extremely important triangle. If you're trying to integrate to find arc length, as you will later on in the course, you got to have an expression for the hypotenuse, all kinds of reasons that you want this. Okay, so what do we have here? The run is x minus x naught. The rise is what? Well, let's replace this question mark with a y, a little question mark. Y equals not there yet. The rise equals y minus f of x naught. Rise over run equals slope. Okay. I'm debating about how much to write here. We take that, do a little rearrangement. We get this, which you've already seen. Okay. This expression here is just slope times run equals rise. So the rise is slope times run, which is f prime of x naught times x minus x naught. By analogy, down here the rise is y minus 3, which is equal to slope times run. Rise has to equal slope times run, because rise over run equals slope, which equals 2/5 times x minus 2. Okay, so key point I'm trying to make is that this expression here is the rise from x naught, y naught to the point xy. Whatever the point xy is, you can get this rise just by calculating this quantity.